Hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. So today we are going to discuss about the topic test of hypothesis in the small sample test. And previous video we have discussed the single mean, but this video is about the two sample mean x1 minus x2, and also we are going to see the degree of freedom problem also in the test of hypothesis of the t-test. Let us consider a problem based on the t-test. Already we have discussed this type of problem. So once again I will recall. There is a 10 students and an average score of 72. Sample deviation is 8 and population mean is 75. You have to test the t-test. If n is equal to 10 means it is small, we have to apply the t-test, and one sample test is x minus mu naught s by root 10 and 75 minus 72 8 by root 10. This is equal to 1.19. So the degree of freedom is 9, and we can move on to the next calculated value. So now another problem is, suppose if we are given a number of delivery times. For example, a food delivery, if we are taking an average delivery time is 30 minutes, means if we take the 16 orders means 32, 28, 35 and so on, means of an alpha of 0.05, we have to determine the t-test at the 30 minutes. And here also we have to apply the null hypothesis and as well as the alternate hypothesis. We can set the null hypothesis for the less than 30 minutes and greater than 30 minutes, and we can fix the critical values 1.753, and there is a number of sample means sample delivery times are given. If there are a number of 16 sample means are given, means we have to find the summation for that. Directly we are not able to apply. So for that we have to apply a formula of summation x by n, summation x equal to 512 by 16. And the 512 is 16. Next we have to calculate the standard deviation. Standard deviation formula is x minus x the whole square. Here the x is nothing but 32, but here x bar is nothing but 32. We have to subtract this two, will get a x minus x bar, and we can calculate x minus x bar the whole square, and finally we can find the total for that. After finding all the value, we can find the sample mean, that is nothing but root of summation x minus x whole square by n minus 1, root of 212 by 15, that is root of 14.13, that is 3.76. After calculating the t-test, and we can conclude the degree of freedom is 16 minus 1, that is 15, t equal to x minus mu naught by s by root 10, 32 minus 30 by 3.76, that is root 16. I will get 2 by 0.94, that is 2 by 16. So final conclusion that 5% level of significance, there is a sufficient statistical evidence to conclude that true mean value is greater than the 30 minutes, and the company claims that an average delivery time is 30 minutes, and we can accept the alternate hypothesis. So same problem, if they ask to find the degree of freedom, means the formula is degree of freedom is s1 square by n1, s2 square by n2 the whole square by s1 square by n1 the whole square, s2 square by n2 the whole square by n1 minus n1, n2 minus 1. This is Mommsen-Welch stat-Welch approximation, and is used to find the two population variance. And the data science team is also given, and they have given the two models for this two sample mean. Here the n1 and 2 sample mean, and mean is also x1 x2, and the standard deviation also s1 s2. They two sample mean is given, means we have to adopt the next formula, that is and this is the formula, degree of the freedom formula. There is a two sample mean s1 square by n1 the whole square, s2 square by n2 the whole square, n1 minus n1, n2 minus 1 2. So based on that category, we can find that 0.96 the whole square by 23, 2.023 the whole square by 18, and you will get 0.0401 plus 0.2274 equal to 0.2675. So the degree of freedom is 8.899 by 0.2675. The degree of freedom is 33.27. The final answer is 333. This is the degree of freedom. So they given the two sample means we can calculate using the degree of freedom as s1 square, and for the t-test also there is another formula, that is x1 minus x2 by s1 square by n1 as s2 square by n2. So this formula we can adapt for the Based on that, next we can see the video of the f test, and f test is the formula for the f test is s1 square by 2 s2 square by 2. So this is the sample difference, s1 square by s2 square, the large sample mean by the small sample mean. And based on that we can see the f test. This is also one of the test to calculate the small sample mean. So thank you for watching this